More examples about this quadratic equation proofs is what you are going to see in this lesson, but please don't forget to subscribe to the channel. Now, here we are going to see now other techniques. Now here, the question says, prove that if one of the roots of the equation, this is twice the other, then 2b squared is equal to 9s. Now, here the idea we use, now here they are telling us one root is twice the other. What we do, we choose the roots. We say, let roots be. Now, if I have one root as alpha, the other root is going to be twice the first root. So, if the first is alpha, it means that the second root is going to be twice this. It's going to be twice alpha. Why? Because the only way we are going to be sure that this one is twice is if this is the same as this. Don't ever bring in beta because you don't know what beta is. But if this is alpha, I know that the sum root is going to be twice this. It's going to be that I just get this time is 2. So this is going to be twice this. So this is how we get these roots. And if we ever given the general equation, it means that the sum of the products is given by this. You see that now in this question they are giving us the general. It means that the product of these roots is going to be this. As simple as that. If they give you a general equation, if they give you something different from this, now we just compare. But if they give you the general equation itself, don't waste time. The sum of roots is going to be this, and the product of roots is going to be this. So now, these are the roots I have. It's that this one is twice this. As simple as that. So this is my pair I'm going to use. So I come and I get their sum. So the sum is going to be, we add them. So we are in alpha plus 2 alpha. But say if you sum them, you get negative b over a if you are given a general equation. So when you sum this is that we have 3 alpha equal to negative b over a. Can we make alpha the subject? Our alpha here is going to be negative b over 3a. Then we come to the product. So if I come to my product is going to be alpha, we multiply now these 2, and alpha to alpha. But we say the product is given by c over a. And from here, so I have 2 alpha squared equaling c over a. From there, if I make alpha squared, the sum that I know what alpha is by the way. I know what alpha is. So my 2 alpha squared is c over a. But from here, know that our alpha is given by this. So you just substitute. So now I have 2 into, now my alpha, which is negative b over 3a. Remember, I'm squaring it equaling c over a. Why? Because we know that our alpha is negative 3 over a. From here. So now, there we just need to expand it. I mean to square. So this will be 2. When I square a negative b, I get b squared over. When I square 3, I get 9. When I square a, I get a squared equaling 2ca. So, we start when I multiply here. So that we are having 2b squared equaling 2c over a times 9a squared. And you see, 1a goes with this. And from there, start now, 9b squared is equaling to 9ac. 9ac as the proof is required there on the equation. As simple as that. Now, this is the square, please. Don't take it as it's the square of the whole of this. It's a square. So you're squaring the whole of this bracket. Okay, now when you come to this, if the sum of the squares of the roots to the equation, this is 1, so that this square is equaling to a squared plus 2s. Now, we know now the roots, what those roots are. So now, we say, in our solution, we say let alpha and beta be the roots. Now, to the equation, ax squared plus bx plus c equals 0. Here, the root are talking about anything about those roots. So now the equation has always so we said let alpha and beta be the roots. Because we're not talking about anything. We are talking about the squares of these roots. So if these are the roots, we always get their sum. So their sum is alpha plus beta, and we say if they give it an equation, the sum is always negative b over a. Then the product of those two roots is going to be alpha beta, which will be equal to c over a. So first of all, we have now the sum of these roots, and the product is given by that. Now we're going to ask that the squares of these roots. So the squares, what are my squares? So my squares are alpha squared, beta squared. Now we are telling you that the sum of the squares, when I sum these ones, I get a 1 from the equation. The sum of the squares of the roots of the equation is 1. This is the statement. Now, what am I going to do? So whenever I have this and this square, we try to express this in terms of a sum and a product like these ones. And we saw that always these ones, whenever I have alpha squared plus beta squared, this is the same as alpha plus beta, the whole squared, then minus 2 alpha beta. Now, so from here, these are now where I have my alpha squared equal to 1. Now I'm going to substitute the whole of this here. So now this will be now alpha equal to 1. Now we just substitute. We have our alpha plus beta. We already remember I said we have the square of cubes. You express it in terms of the product and the sum of the roots. So this one is here. So I substitute negative b over a, the whole square, minus 3 into my alpha beta, which is c over a, equaling to 1. When the square b is negative, we get b squared over, when the square is a, get a squared. This will multiply with 2c over a, equaling to 1. So we multiply it by a squared. So a squared minus b squared minus a squared minus 2c over a equaling to 1 minus a squared out. But this will cancel this. 1 will cancel this. So we have now b squared minus, this will give us 2ac equaling to a squared. We come out to so that they are making b squared, the subject. We take it this side, it's at our b squared. We have this a squared. When this process equal signs, it becomes positive to a c, and that becomes our answer. So that's it, members. I wish you well.